Today's topic is scientific notation. We're going to be talking about briefly what is scientific notation, but more importantly, we're going to be talking why do scientists use scientific notation? Why do they have a special way of writing down numbers? So first, to review a little bit, scientific notation, let's say I had a number like 500, and I wanted to write that in scientific notation. I would first, the decimal spot would be right there. I would move the decimal spot over 2, and it would be 5 times 10 to the 2 because I moved it over 2 spots. So this is what we would call 500. We would call that standard notation. That's the way we normally write things. Whereas 5 times 10 to the second, this is our scientific notation. The important thing about the scientific notation is this is a number between 1 and 10. So it's important that that's between 1 and 10. And then this is going to be 10 to the power of a number. It could be a negative number or a positive number. So now moving into why this is important. The first reason is that it makes it really easy to read and write very big or very small numbers. So frequently in science, we got to talk about things on a very large scale or very, very small scale. So our numbers can get a little bit out of hand if we don't use scientific notation. So for example, if we're talking about an amount of atoms, maybe of water, and I should say molecules of water in maybe a glass that you're drinking, it might be a number like that. Really, really big. If you're looking at it, it's very easy to misread that number. And oftentimes we put commas in there to help us keep track of all the zeros. But even if we put commas in here between every 3 zeros, it's still extremely hard to keep track of. But in scientific notation, it's significantly easier. So we could count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we're moving the decimal spot over 23 times. And we could turn this into 6.02 times 10 to the 23. So you see I had to make this number between 1 and 10. And then that is how many spots I moved the decimal over. If you have a number greater than 1, this will be a positive number. Whereas if my number is less than 1, it'll be a negative number. So I'll do another example. Let me push this up a little bit. And let's say I had, maybe I was talking about something like the width of a hair. So something 0.0000, and hair varies in width, but we'll say it's 0.000087 meters. We can rewrite this in scientific notation, going over 1, 2, 3, 4, 5. So we'd be moving over 5 spots. So it would be 8.7 times 10 to the negative 5. And it's negative because this number is less than 1 and we're moving the decimal spot to the right. So that's one reason why scientists use scientific notation. The second reason, and we just recently talked about significant figures, is it makes it very clear how many significant figures a number has. So if we take a look at these two numbers I already did, the significant figures are written out directly for us. We have 3 significant figures in that number. We have 2 significant figures in that number. So we'll go through an example of where it might be tricky in standard notation, but then scientific notation clears that up for us. All right, so let's say we measured a distance between towns, and we got the distance was 40,000 meters. Looking at this number right here, it looks like we have one significant figure, just that 40, or sorry, just that 4. But in reality, let's say our tool was good enough to give us significant figures to the nearest 100. So in reality, our tool is accurate to the nearest 100th spot. A way that we can show this in scientific notation would be, we would just write it out in scientific notation, using what we know to be 3 significant figures of accuracy or precision. So we could write this out as 4.00, because that's how many significant figures that we said we had with our tool, times 10, however many spots we moved it over, 1, 2, 3, 4. And that would be a way of showing 40,000 with our 3 significant figures that we measured. Otherwise, when we just write it out 40,000, it looks like our tool was very unprecise and it only has one significant figure. So that is another reason why scientists use scientific notation when writing their measurements, because it's very clear to see how many significant figures are in your measurement.